Hello and hi to everyone. Good morning, good afternoon, and good evening to everyone from around the world. Please kindly switch off your microphones and camera for now, as we are starting in a short while. Okay, before that, thank you once again to join another interesting webinar from Securiton. A warm welcome to all the audience today. Without any further ado, I will proceed with the agenda for today. And our agenda for today, as per the topic, ADW Linear Heat Detection Application for Floating Roof Tanks. That's the idea and the topics we're going to discuss. I will start with the introduction of the floating roof tank. We need to understand what's the roof tank all about, followed by floating oil roof tank fire incident. So we need to understand more about the incidents around the world, what have caused them, to understand the structure of it. Third, I'll be covering on a topic of code of practices and fire standards available concerning applications towards oil roof tanks. And after that, I'll be giving some information about how the solution were given towards the floating roof tank, practically on the Ream Seal application. And finally, I do a conclusion, including some references from Securiton that we have done to prove to you that this is the ideal and the best solution for floating roof tank. Good. And about myself, let me introduce myself. My name is Seelan, and I've been with Securiton for the last 14 years, based in Malaysia, taking care of projects as well as engineering support in Malaysia, as well as Asia Pacific and Middle East, up to Africa and certain other countries around the world. And let me go into the topic. Today, we'll start with the introduction, as I mentioned, and we will try to understand what is floating roof tank. Okay, floating roof tank is actually a storage tank and commonly used to store petroleum products, petrochemicals, made products sooner or later, and usually it's also called crude oils. So crude oils are stored into this storage tanks, and that can be a permanent storage tank or a floating types of roof tank. Normally it consists like a cylindrical type that you have seen around the world, and it's a steel shell, and most of the cases they try to have a floating type of roof tank because there is a tendency to put in the crude oil, and there is a time for you to take out the crude oil from the roof, from the cylindrical roof, floating roof. That also makes the roof rises as well as fall within the liquids level of the tank. So when you started to fill in the crude oil and the float of the roof happens, and when the liquids are being taken out during the time, so the roofs will drop down. So there is a ream seal around, or the rim of the surface, which actually gives a friction. That is the major causes of incidents in normal cases of a floating roof tank that we will look into today. And with that, we need to understand how the structure looks like. So I'm going to explain a little bit about the structure of the external roof tank. As you guys know, there is an external as well as internal types of roof tank available. What we're going to discuss is basically on the external type of the roof tank. And here, as you can see on your right, it's a left, on your right, a construction of a cylindrical type where there's a rod and ladder towards the top. And the components involved is obviously the tank itself and the foam area and the rim seal itself and the shield around the rim, as well as the weather shield to protect the rim seal areas, and a foam solution. In most places, they have this foam suppression that is available to suppress. It'll be placed on top of this tank itself. So the most of the components, electronics and extinguisher, even the detection systems, are placed on the top of the roof. And so most of the incidents or casualties can happen on the top of the roof tank. So that's where usually we need to look into serious protections needed. On your left, you can see a side view of how the platform looks like, and the rolling ladder, which actually moves, and the cabling needed extra so that it works according to the movement towards up and as well as towards down when people are putting in the crude oil inside this roof tank. Good. So that's basically the constructions of a roof tank, as well as what is external floating roof tank. So now the problem we're going to look into is what are the causes of fire and what have happened previously in terms of fire incidents in floating roof tank. For that, I have taken a readout from NTSB, an investigation from US, and up to 2007. Yeah. Okay. This have indicated the US-based report has indicated some factor that caused fire incident in storage tank, and the main contributors are the lightnings and the oil spillage, as you can see, followed by other incidents such as nearby explosions, static charges, sunken of the floating roof, overpressurization, earthquake, which is unavoidable in certain countries, sabotage, which is human error and humans started to do something abnormal towards the floating roof tank, and the heater malfunction. And the same research is also mentioned under the research. Their descending orders have given what are the main causes up to the spill of roof tank can happen. One is overfilling, which means human error for sure, because they didn't monitor exactly how when during the filling of the tank that it's overfilled and it can cause the fire. Because you see, overfilling is also mean the Ream Seal moving faster and slower, and that can cause a friction and gives a fire damages can happen. So another reason, second main reason is damages on the roof itself, and the roof drain failure also caused one of the fire incident. Gas and high vapor pressures product entered, and roof cracked near the pentons, as well as damages of the seal. As I mentioned earlier, seal is the basic construction where it moves. The movement mostly happens in the beam sealed area. That's where the damages can cause a fire. And overheat of the product itself, because as you know, it is external and it's exposed to sun, and overheating is possible, and also cabling issues can also cause the problem. And followed by roof landed with some legs down, because as you know, there's a construction, and the construction failure can also lead to that. Heavy rains, that can be any catastrophic events can happen near the area where the floating roof tank. So these are the common incidents from this research I've mentioned that have causes the fire. So there can be human errors, can be also because of Mother Nature, and sometimes because the human error of conducting certain activities in the floating roof tank. To understand further, I'm going to show you guys one of the incident which happens in 2007. I took out from the same research paper, NSTV investigator. And here, as you can see, this is a real fire. It happens, and it's about 80,000 barrels of crude oil, it's a diesel oil. It's a petroleum storage terminal. And the main issues here is 21 hours it took. The burning happens. As you are aware, crude oils, diesel, petroleums, and all these are fall into a highly flammable liquid. And this liquids, if you started up a fire, to extinguish this fire, it takes sometimes a week. I have another incident that it takes a week to suppress, because the size of the floating roof heat tanks itself, and equipments and types of extinguisher used also makes a crucial in order to suppress the system. In this case, it took 21 hours, and the damages for the nearby storage tanks also affected as well. So the total loss here is about $2 million US. And the nearby residents were evacuated, schools were closed for 2 days, and all this issues happens after the incident of this fire. Okay, and the research also, after tedious investigation was carried out, and they found out as an improper procedure for switching the content of the tank from the gasoline of the diesel oil was the issue. So static issue was there, and the way humans handling is also the cost, and the dual cost has make the catastrophic event and the fire incident happen. So the takeaway from this incident would be, first, the crude oil and is a very hazardous liquid, and it takes time to extinguish. So we need to find a proper early detection system in order to send the signal to the earliest possible extinguisher system to suppress it. Second, the total loss and the cost of the damages is quite a huge one. So the early detection is always needed to minimize the damage and the losses here. So for that, we have to look into the best solution to have a fastest detection possible to extinguish the system at the early time possible. For that, what we need to do, we need to understand what are the systems to be installed and how shall we install to make sure the fastest possible suppression and detection and suppression could be guided through. So for that, I'm going to share with you some of the fire code and practices that have been used in order to to cater with the floating roof tank application. Here, basically, as you know, we have NFPA 30, which is 2015 Flammable and Combustible Liquid Code, FM Global, which is Property Loss and Prevention Data Sheets, which is 7-88, where you can look into it. OSHA standards as well, NFPA standard, NFPA 72, which is the common standard for all the fire alarm systems available. And of course, 101, which is the Life and Safety Code, which you have to look into it. So I'm going to give you a summarize of all what these codes have to say. Most of these codes and standards will explain to you how do you handle flammable and combustible liquids, gases, and they were not narrow down into a detection system. They said you need to look into the fastest detection. So we have to interpret from here to look into the fastest detection possible for such incident. To be as a guideline, we look into this as a guideline to make sure that what is a perfect faster detection is possible. You can use a point type detector, which is may not suitable for such application in external, which is outdoor application. So we have to think and find the best product which works with such bizarre environment. Okay, so this is talking about the international practice code and standard. But you must always remember, we must look into the physical limits of the ADW, which we're going to explain to you guys what is the limit of the ADW and what is the specification. For example, I'll take EN 54-22 because this is our products are certified under EN 54-22. That tells you exactly what is the type of installation, what is the guideline you do in order to do a protection or insulation in any premises that includes floating roof tank. And basically, in the other one, you have to look into your local standards because you see, this is an international. I mean, you know, certain people are joining from different countries, different part of the world, and each and every countries have their own regulations and guidelines. For example, Germany, they have VDE, which is VDS, and Malaysia, for example, we have MS standards, which is comply with the BOMBA, and another example for Indian standards, we have IN Indian standards, which is available in India, and it might be different from country to country. So you have to also take the physical limit, look into what the EN 54-22 has to say, because we certified under EN 54-22, and you have to look into what are the code and standards available in each of the countries, and you look into the best solution. Good. With that explanation, then I'll explain to you why we need this fire detection system. Okay, as we know, as I've shown you earlier about the incident from the research paper, how long it takes to extinguish and what are the issues that we face here. And here, why we need such a detection is because it's flammable liquids and it leads to a major fire events. Okay, as mentioned, there are 9 major incidents happened from the research itself. And if in terms of a fire breakout, you need an early detection that it's possible to contain the blaze as well as to extinguish as fast as possible. So the damages can be suppressed as early as possible without spreading to another nearby floating roof tanks as well. And here what we look into is normally in the normal cases, the factory or the people will make sure that it has to have LHD insulation, or in the short form is LHD, is linear heat detection system, which has been a conventional solution most of the time is the roof tank, because of the flexibility that it can do. At the same time, the faster detection it could give you in return. So this techniques obviously requires a heat cables running around the floating roof tank seal, which is the Ream Seal application, we call it in the other word. So the Ream Seal is where we need to cover, and the protections were given, which we will look into our solution in a short while. In order to do that, obviously we need the right product to work with it. So as a Coreathon, we actually gives you two types of ADWs available, which is ADW 535-1 as well as ADW 535-2. This has two detectors as well as two sensing possibilities, or two zones possibilities, or one zone possibilities. And the maximum that we can cover is up to 200 meters according to NFPA 72, which I mentioned earlier. If you wanted to follow the international standards, we have two. One is the EN 54-22, where we are certified from. That goes up to 115 meter. And the other one is NFPA 72, which you can go up to 200 meters, which is also the system limits of the ADW as well. Okay, we can also use copper, stainless steel, or Teflon in any of the combination in order to do the detection system for the ADW. Okay, you can also do a T piece or a single round around the Ream Seal is possible. Good. Before I go to the solution, I'm going to stop for any questions from the audience before I proceed to the solution of this. How do you integrate the ADW into Ream Seal?
Seelan, I've got a few questions. So one of them is there a difference between a floating and a non-floating roof tank in terms of installation?
Basically, to answer this question, they're quite similar, but the other precautions you need to take, I'll show you guys in the solution, whereby extra cables were needed, special place to cap these ADWs is needed because it's moving and it's also floating in terms of the Ream Seal application. In terms of the external, it is stagnant. Therefore, a permanent place to put the ADW is enough, and no need extra cables were done. Otherwise, in terms of how you run the cable and detection would be the same.
And will lightning cause any issue for installation, since this is mainly an outdoor application?
Yes, it does give you an issue. As I mentioned earlier, one of the issues before from the research paper, lightning, heavy rains, it also causes issues on the applications installed. Well, so we have the right precautions, which I'll also explain, will be explaining in the solution part, where you need to put into a weatherproof box as well as explosion-proof box, and you have an insulator, whereby we can use copper together with the hard plastic tube in a combination where a static will not pass through from the copper coil or the stainless steel towards the ADW. Any other questions?
Yes. And how do we solve the issue with distance of roof tanks and viewing in central station that can be kilometers away? So how can you view?
So this I will be also explaining in short while in one of our key point of ADW, whereby our ADWs are capable of doing integrating networking among themselves and can be viewed, and a proper converters can be used. We work with LAN and it goes to 100 meters, but in terms of a distance, we can use the right proper fiber converters to convert the distance that required in the site, and you can have distance away floating roof tanks with our ADWs connected at the control station somewhere else. It is possible.
And what is the suggestion on type of tube used for floating roof tank? Is it copper or stainless steel?
Both, it's possible, but mostly in most of the countries and requirements, they prefer or to use stainless steel because of robustness and also the cleanliness, as well as to maintain the cable, the detection system is better. So it's always advisable, it's recommended to use stainless steel.
So we don't have any questions further, so you may continue.
Perfect. Thank you so much, Zach. I'll continue with the solution. Now, hold on, guys. Okay, so in terms of solution, here what you can see on the screen is the the roof tank from the top view, and the detects a fire, and the rubber rim seal is the white color area that you can see, and ADW is placed on top of the roof tank itself, mounted on the X-proof weather box. The questions earlier was the weather issues and whatsoever can be solved by putting into a weatherproof box, as well as that box has to be explosion proof. Please do remember this application usually falls into zone 1 or zone 2, and at times at zone 0, depending on the flammable gases of the roof tanks are manufactured and used for. That is also into the liquids there, the liquid types classified by the end user. So if it's actually zone 0 or zone 1 or zone 2, then you have to make sure that the weatherproof box comes with the explosion according to the codes and standard, which is 0, 1, or 2. So these are the standards which you have to look into it. With those weatherproofs and mounted box will be placed on top of the roof, and then the signals will be sent throughout the right converters, which is from the LAN towards the fiber optic towards the nearest central station, which can be placed away kilometers away from the roof tanks. And as you can see, copper sensor tubes are installed surrounding it. As I mentioned, copper or stainless steel, but practically stainless steel is the best one, as we have a track record in many installation in India, which has proven a better remark in terms of functionality towards the rim seal. So that will be around the area where the rim seal. So the idea of protection would be around the rim seal. Okay, why it's around the rim seal? Because rim seal is the area which is prone for fire incident. As the rim moves, which is the roof moves ups and down, there is a friction that happens within the wall as well as within the rim seal that actually causes fire for some reasons. And the damages, as I mentioned earlier, weathers and the aging processes of the rim seal, many other causes, reasons behind the fire that can happen. So that usually happens around that area. Then that's where the ADW can capture it as fast as possible and be extinguished as possible, as early as possible. This is a side view of earlier from the front view. Now we go to the side view. As you can see, the blue color on the marked here is actually the Ream Seal area, which is area where you need to put the ADWs, copper coil, or a stainless steel detection cable. Good. Now I'm going to show you on the other side view the details as well. Another complication that we might face here is because the movable ladder as well as the movable roof. So, and the ADWs can be on the top, and the connections from the ADW will go to the nearest stations, which is there is a cable. So you need to give an extra cables, power cables and signal cables, so that the cable, access of cable, can move freely when the operation of the ream seal is going on. When the ream seals roof tanks are being filled, the roofs may go up and may go down. So this, you must keep the provision of the right cables so that the cables will fluctuate according to the need of the roof tanks as well. So that make sure that you don't have any obstructions in terms of the signals being cut because the cables got issued. So this has to be taken care when you do applications towards the tank, roof tank. And here, as you can see, on the roof tank, on the other side, there is a rubber rim seal and on it, and the ADWs will be placed underneath the sun protection. As you know, one of the reasons I mentioned also on the research paper that the weather is an issue, but if it exposed, our sensors are completely exposed to the sun, you may have false alarm time to time. So to avoid that, you need to make sure that the sun protections or a heat collection roof are being made and the copper or stainless steel being placed underneath the sun protections or the heat collection roof. So this will avoid a direct sunlight being targeted towards the copper tube, and this will eliminate any false alarm on the ADW applications on the roof tank. Good. So these are the precautions and the idea of how to install the ADWs on roof tank. And in order to understand about the Ream Seal, is because that's the major issue where protections are needed. There are different types of Ream Seal available. One is the secondary seal type, and Gravinius form seal type, mechanical seal type, double seal, and also tube seal. But basically, you need to understand the construction might be different, but you have to make sure that usually the double seal will have the shield on the side of the thing, and you can put it, the ADW at the back. You don't need additionally to put it in weatherproof because it's already covered. But in terms of the mechanical sealed and the secondaries, the tube seal, then probably you need to do an extra seal to seal our ADW. But otherwise, the secondary and double seal already have a shield around it, and you should not have any problems of additional workaround to cover up this ADW from the copper coil from sunlight protection. Okay, so we have talked about everything about insulation. We talk about detection from earth and insulation about ADW. But the issue is always about fire. Okay, if in case of fire, how this ADW will work, obviously the fastest possible, and what it does, what is the signal is being sent, and what are the other things that be incorporated to suppress. Mostly, this will be sent into a nitrogen form solution available on which is placed on top of the Ream Seal itself. So the earliest possible signal will be sent towards the pneumatic discharge valve, which is usually in terms of protection, they are connected to a PLC, and that works according to double signal or rate of rise plus maximum alarm, or whichever possible from our detection side. And these signals shall be sent to their valves, and the PLC will work, and those signals will give the right command to extinguish using the nitrogen form solution. Okay, as part of Securiton, we give only the detection protection, but we have the relevant people that we can give you an idea how the suppression works itself. So we can give you some ideas and solution from our successful stories, which I've done in numerous places in Asia as well as in Europe, which I'll show you in my reference list later. So that's all about the solution that we look into our ADW. Now for that, the best thing, as I mentioned, is our ADW 535. I'll give you some of the key components that our ADWs could be the best solution in terms of the detection. As you can see, the outdoor, I think this is an external floating roof tank, and the challenges are quite bizarre because there are many changes happen in terms of seasons. For example, if you look at, there are 4 season countries available in Europe and some other countries as well, where 4 different climates in different temperature range around the year, and this can be a challenging solution to look into it. And during the winter, the ADW may perform different, so it has an adaptation that you can able to read and to adjust it by itself, so we don't have any problems of weather that gives you a false alarm, or it does not work during this different climate, so we don't have any issues on that. Lightning, okay, as this question raised before, is the common problems when you are outside. So we don't have a problems. Why? Is because we will have a SS tube or copper tube incorporated with a hard plastic tube before it enters the ADW. So in terms of if it's intact with the lightning, it is not conductive. It will not conduct those signals back to the ADW component itself. In terms of animal vandalism, as you know, it's sometimes it's in the middle of a desert, and it can be somewhere where animals problems will be there. As you know, our detection system made of copper or stainless steel, so any problems towards animal vandalism, so we should not have a cause of that. And real fire incident, as you know, in most cases, this is crude oil we're talking about. As I mentioned earlier, if the fire happens, it takes 21 hours to extinguish a fire. So you know how dangerous it is and what can happen after the fire. Usually, even a crude oils would burn about 600 over degree, whereas our copper or stainless steel have a tendency to melt at 1000 over degree. So as you know, copper can go 1000 over, and stainless steel can go around 1,500 degree. So even after fire, it is reusable. Changes not possible. It's not needed if you look into the real situation here. And the routine maintenance is easier because you can just come to the ADW and do the testing, and shouldn't be any problems. In terms of sabotage, as you know, it's quite difficult, and if it's there, somebody tried to steal or whatsoever, and any detections in the real situation, if there is a cut in this copper tube or stainless steel, the ADW will perform a cycle check to see whether there is a leakage or breakage, and gives you a fault immediately within the period of 5 minutes. Less than 5 minutes, it should be able to give you. This is also according to the EN 5422 rules as well. Okay. With that, I will give you some of the key components of our design. Our design consists of the main evaluation unit, which is the evaluation unit can sustain up to 60 degrees. So obviously it has to be into a weatherproof box. And the copper and stainless steel can go up to 180 degrees, okay, in terms of operational condition. And here you have a pressure sensor and a tube monitoring. Then we also have the main board inside. An extension board is available. And also an SD card can be placed inside for loggings as well. In terms of additional cards, we have Security Line integration module if you wanted to integrate with fire alarm system. A networking card, which is RS485, which I mentioned earlier. If you don't want to work with the LAN, which is incorporated with ADW, you can use the networking card, which can go 1,200 meters. But in the case of a great distance, you can use this RS485, convert into a fiber, and reconvert into RS485 to get to the destination, so that you can use it when it comes to a greater distance. This is also possible. In terms of relay, on board, there's 4 relays available. Additionally, you can have 5 more relays, and that can be incorporated to give you additional signals, such as pre-signals and the main alarm as well. And we have all this relevant software to work with this ADW. That would be the ADW Heat Calc, as well as the config software. The Heat Calc is for the calculation tool to calculate and to get the right confirmation before you proceed to commission using the config software, which is a tool used to commission to maintain the system as to retrieve information when it's needed. With that, I'll go to the networking, which is one of the questions raised earlier, whereby we can use the LAN itself, or you can also convert the LAN connections into a fiber and reconvert, and you can view this in a central place. And you can also recommission the system from the central place. You don't need to climb up the roof tank to look into what is the problem, so you can get most of the information. Only troubleshooting, you can have to go to the floating roof tank on top of the roof to do solve. So all this information can be retrieved from a central station. With that, we also need to mention that we have few signals available, which is the rate of rise, maximum alarm, and if it's a 2 detection system, we can also do a faster and slower detection, so that we can do a double dog solution as well. If you look into it, because we have 2-zone system, ADW 535-2, which could able to get 2 signals, and you can have a double confirmation, so that makes sure that extinguisher is being done in a proper double confirmation. So that's also possible from our ADW. So with that, I would like to conclude that ADW is the most reliable heat detector that I've seen that around the world, because it's a system that don't need maintenance or minimum level of maintenance needed, and it has the earliest possible of heat detection system. And it's, as you know, it's weatherproofed, it is sabotage proof, and most of the significant features available, which I've explained earlier. And it's also has our auto-referencing, and we don't have any issues with climate changes, and the most flexible heat detectors, because multiple alarms available, ROR, as well as pre-alarms available, and all the relevant relays are also available to work with double knob and other relevant information that you can work with it. And because it's a metal sensing device, and it, of course, obviously it goes in the longer terms into the lifetime of the device itself, because stainless steel and copper, it can go longer, and it will not have saturation issues in terms of the workability or its functions. Good. So that is the conclusion for today. With that, I'll give you two main references that we have around the world. We have done numerous of installation in India, and is one of the most seeked device to be installed because of all the benefits that I mentioned earlier, because we have all the flexibility to work in such environment, and the duration of working, it's quite long. It's proven. Sometimes we have been in installation for more than 20 years in India, whereby we have minimum troubles in terms of ADW. We have installed for Indian Oil, Bharat Oil, and ONGC as well in India. And this is one of the real pictures taken from the Gujarat, India. And that's talking about the floating roof tank. We also have the non-floating roof tank, which is one of the question rise. Can we use in terms of covered floating roof tanks? It's also we have installed in Lithuania as well. And with this, we have also a number of small insulation tanks is also done in Asia as well, in Indonesia, in other part of Asia as well. And that's the key point of this installation, is because our ADWs have lots more benefits, and in terms of environment that it can cater to, it's a great area that it covers. So with that, thank you everyone for joining our webinar for today. And I hope this takeaway would be benefits to most of the audience who joined my webinar. And we will look forward for the next coming webinar soon, and we'll be informed. And you can also check our our website as well as our LinkedIn and our social media, whereby if you go to our website, we have informed about the next webinar and the dates, and you can register for the next interesting topics that we would like to cover for the international audience. Thank you.
Silan, I've got a few questions.
Yeah, proceed.
Can we network the ADW for many roof tanks? And if yes, how many? And what is the distance possible?
Okay, good. As I mentioned earlier during my presentation, so if you use an RS485 technology, you can go 1,200 meters in terms of total distance. It may not be enough for a certain application. In that case, you can use the fiber converters to convert, and that can be a multi-mode or a single mode, which you can extend from 3 kilometers up to 6 kilometers, depending on the area. And you can also extend with a booster as well, RS485 booster, to extend the device. And to answer the next question is number of ADW can be connected. 100 number of ADWs can be connected together and viewed in the config software.
And what is the lifetime of the products to work in such an outdoor environment?
Okay, so as electronically, we talk about the temperature versus the lifetime of the device. The higher the temperature, the lower the lifetime of the device. So the colder the environment, the higher in terms of the lifetime of the device. So with that needs, normally this is outdoor, so the extreme environment, usually it's more than 10 years, we would say. And the mean time between failure from Securiton is more than 20 years. But even to prove that, we have proven that our first generation ADW, which is installed in India, worked more than 20 years without any major issues. So we would say more than 10 to 20 years, we don't have any major issues in terms of the lifetime of the ADW. If a frequent maintenance were carried out, and you can sustain the ADW for a longer period of time in terms of the functionality.
And the last question I have is, since it is installed outdoor, how frequent would be the maintenance to be carried out?
Good. So this might be depends on country to countries and requirements that has been raised from country to country. For example, I'll take one example from Thailand. For example, the end users have specified every 6 months that there shall be a routine check. From Securiton, we recommended every 6 months that we should do a maintenance. In terms of maintenance, it's very easy. We do have a test coil. With that test coil, you can do an activation, a dummy activation, to see whether the ADWs are performing, and you can also switch off all the outputs and do the right checking without doing a real fire incident. Okay, So that is also possible. So 6 to 1 year, depending on the application. In terms of the roof tank, I also would suggest 3 to 6 months routine is applicable.